Welcome to another Arduino 101 video. As always, in these videos we do something more than just basic Arduino programming. And today we will see something that even myself didn't know it was possible. Instead of writing the code to the Arduino, we will see how to extract an existing code from the Arduino and save it in an hexadecimal format, which basically means ones and zeros. I will show you how the code is stored and burned to the Arduino and what software we need to extract it back. And then I also show you how to write back that extracted code to the Arduino. Sounds interesting? So let's get started. My new project was requiring some flexible PCBs, and PCBWay was the right solution for that. And the order process is so simple. Just go to PCBWay.com and select Flexible PCBs. Upload your Gerber files as always and select your settings directly on their website. You also have the option for Rigid Flex PCBs if you want, and other settings for the color, the thickness, the gold immersion, and so on. I received my PCBs in just a couple of days, and they look amazing. The tracks are very small, but even so, PCBWay did a great job, and they have capabilities that go even lower than that, and you could check them on their website. So try yourself their services for flexible PCBs like mine, and like that you can complete your awesome project. And check more for other services for prototyping PCBs, automatic assembly, SMD stencil, and much more on PCBWay.com. What's up, my friends? Welcome back. This here is an Arduino, obviously. But despite how we all call it, Arduino is not a microcontroller. The Arduino is just the name of the development board, which is made out of the PCB, the plastic pins, also some voltage regulators, the connectors, and everything that you see on this board. Because the real microcontroller is this one here, and in this case is the Atmega 328P, and is made by a company that is called Atmel, or nowadays was acquired by Microchip Technology. So why am I telling you about this? Well, because I want you to understand how the code is uploaded to a microcontroller, and you have to understand that the microcontroller is not the entire board, just this chip here, and it could be any other chip. But basic Arduinos are using the Atmega chips, and these have an AVR structure. You have to understand that inside such an AVR microcontroller, we have the main CPU, we have some flash memory, EEPROM memory, and SRAM. So we don't need any external memory for most applications. Almost all devices except the small tiny AVR chips, such as the ATtiny85 and so on, have a serial interface, which can be used to connect larger serial EEPROMs or flash chips in case that you need more memory. And these external memories come in the form of other chips like this one here, which has an I2C communication in this case. So AVR structure is using 32 registers of 8 bits. And the code that we upload to the Arduino, so the program instructions, are stored in a non-volatile flash memory. Although the MCUs are 8-bit, each instruction will take 1 or 2 16-bit words. The size of the program memory is usually indicated in the naming of the device itself. For example, the Atmega 64X has 64 kilobytes of flash, while the Atmega 32X, which is the one that the Arduino Uno is using, has 32 kilobytes. So for these microcontrollers we have no external program memory, and that means that all the code executed by the AVR core must be inside of the chip, on its flash memory, and that's the part we need to extract in this tutorial. Basically, inside of the Arduino we have the program memory, the data memory, and the EEPROM, and we will focus on the program memory. This memory is separated into the boot flash section and the rest of the code. And we don't care about this boot section for now. So our code will be stored here. This, for example, is an Arduino code. But when this is programmed to the chip, it is not stored in a text format like this. The compiler is in charge of translating this text into zeros and ones, and then to store those zeros and ones to the memory. For example, this is the binary data for this blink code in hexadecimal format. And this is what we want to extract today. So that being said, let's see how to do it. To be able to see the differences later in the video between what we upload and what we extract, I've prepared two blink codes. One blinks each 100 milliseconds, and the other one will blink each 2 seconds. I upload for now the 100 milliseconds to the Arduino Uno. And as you can see, the LED is blinking very fast. So now go ahead and download this software from below. It is called AVRDUDESS. Install it and run it. To communicate with the Arduino, we can't use the USB connector. We need to create an ISP communication. These are the pins for an ISP communication on pins 10, 11, 12, and 13. So for this you could use an ISP Programmer, but in case that you don't have one, we can use another Arduino as a controller. To make the difference, I will use a red Arduino for that. So this will be the master, and this will be the Arduino from which we want to extract the code that we have uploaded before. So first we get the master Arduino, connect it to your PC, and run the Arduino IDE. And here we go to File, Examples, Arduino ISP, and we open this example code. Select the Arduino Uno board, compile, and upload this code to the master Arduino. And just like that we make it act as an ISP programmer. Now you have to make these connections from the master Arduino to the Arduino with the blink code. And these are the ISP communication pins. And now get back to the AVRDUDESS software. For programmer, obviously select Arduino. Make sure that you have the master Arduino USB connected to your PC. And in the COM list, select the COM of your master Arduino. In my case is this one. And for the baud rate I set it to 19,200, but in your case it might be 115,200, because I've seen some other models working at a different speed. Now on the right side for the MCU, select the Atmega 328P, because the Arduino Uno is using that chip. And now click Detect, and if the ISP connection between the master Arduino and the code Arduino is good, you should get this message. Okay, so now as you can see we can access the flash memory where the code is, the EEPROM memory, and the fuses configuration. Let's go one by one, starting with the fuses. And these fuses are like switches, and they could be 0 or 1, and they basically control the configuration of the microcontroller. For the Arduino we have the low fuse byte, the high fuse byte, extended, and LB fuses. The low fuses will deal with the clock sources, and each bit will control something as you can see here. And the high fuse bits will control these parts, such as the reset, the watchdog, the bootloader memory, and so on. So if an Arduino code has changed these bits, you might also want to get these values as well when you get the entire code. So in the AVR software, you click the read button next to the fuses bits and get these values. And there is no way of storing this, so you must write down these values. Maybe open a notepad and paste those values there. Okay, so now we have the fuses. Next, let's read the code. You have to mark the read checkbox for the flash memory. And for the format you select the Intel HEX for hexadecimal. Now click the three dots and select where you want to save the code file. And I give it a name. For example, in my case I name it blink 100 milliseconds.x, and I save it in this folder. So now that you have the file root, make sure that you have all the settings as I have, and click go. And the code is now extracted from the blue Arduino. The process is done. I go to that folder, and as you can see, I have the hexadecimal file of the code. And these are just ones and zeros, but they contain the blink code. And now we do the same for the EEPROM memory. Mark the read checkbox, click the three dots and give it a name. I name it EEPROM 100 milliseconds.eep. And now click the go button. So now the EEPROM data file is now extracted from the blue Arduino. So now we have the fuses, the flash data with the code, and also the EEPROM. But why do we need the EEPROM? Well, because some codes might use the EEPROM memory as well. For example, for my soldering iron project, I was storing the user settings on the EEPROM. So if you want to copy the entire code, you might also want to extract the EEPROM memory. Okay, so finally, to demonstrate that the code that we have extracted works, I take the blue Arduino and using the Arduino IDE, I upload this code with a blink of 2 seconds this time. As you can see now the LED is blinking a lot slower. And now connect back the blue Arduino to the master Arduino with the ISP connections. We get back to the AVR software. And make sure that you have these settings. In the flash part, we now select the write option. Now select the hexadecimal file that we have extracted before from your PC folder. We also mark the Erase Flash and EEPROM checkbox. Now click Go and the new code will be uploaded to the blue Arduino. Once finished, remove the reset wire or disconnect all the ISP pins and reset the Arduino. And there you go, we now have the 100 milliseconds blink instead of the 2 seconds one. We have successfully extracted and programmed back the code from the Arduino. Okay, so back to the AVR software. If you want to fully copy and upload the code, you must re-upload all the parts. So get the fuse values from your notepad file. You place them here in the software and also check the Set Fuses checkbox. Then select the hexadecimal file of the code and check the write checkbox. Then you also select the EEPROM file and also check the write checkbox. Make sure that all the settings are correct for the MCU type and the speed. Check also the Erase Flash and EEPROM checkbox and click Program. And now all the 3 parts are uploaded to the blue Arduino. And just like that you have copied the code from the Arduino and uploaded it back. And have in mind that you only have access to the hexadecimal format of the code. You won't be able to edit this code in the Arduino IDE, for example. You can only copy it and upload it again, without editing the code. And you can do this with the Arduino Uno, an Arduino Nano, or even an Atmega 328 chip that is soldered to a prototyping board. All you need is access to the ISP pins. So guys, I hope that you have learned something new. If so, consider giving me a like or comment below. Thanks again and see you later guys.
Hey guys, so we are at the end of this video. So some of you guys are supporting me on Patreon and thank you very much for that, because thanks to you I'm able to buy all these components and the modules that I use for my tutorials. And if you would like to support me as well, you have the links for my Patreon, for my website and my shop below in the description. Thank you for everything.